Good morning, children. In today's class, we are proceeding with hypothesis testing. Hypothesis testing, when we say we have three types of tests: two-tailed, right-tailed, left-tailed. Two-tailed tells me H1, the alternative hypothesis, mu not equal to mu naught. That is, the region of rejection is on either tails of the normal curve. But when I say the right-tailed test, we say mu greater than mu naught. So, we have the region of rejection only on the right tail of the normal curve. Left-tailed test H1 colon mu less than mu naught. We have the rejection region, or in other words the critical region, lies only on the left tail of the normal curve. So right-tailed, we see the right end alone, left-tailed, we see only the left alone, and when it is two-tailed test, I have both the ends. Let us do the exercise problems and understand these concepts well. Exercise 8.2, question number 14. A sample of 100 items drawn from a universe with mean value 64 and standard deviation 3 has a mean value 63.5. Is the difference in the mean significant at 0.05 level of significance? As we read the problem, let us try to understand all these values. Sample size. A sample of 100 items tells me small n equals 100. From a universe, the word universe tells population with mean value 64. Population mean value 64. Population mean mu is 64. Population standard deviation 3, sigma value is 3. The sample from the population of all this has a mean value 63.5. Link it like this way. The sample taken from the population of all these details has a mean of this. So, sample mean is 63.5. Is the difference between the mean significant? Level 0.05 level of significance. We remember the value 1.96 when it is two-tailed test. Null hypothesis H0. Since we are going to test it in all the problems, remember to write it. H0 tells me mu equal to 64. Alternative hypothesis H1, mu not equal to 64. So they have given mu is 64, which you take as H0. When I say not equal, it's a two-tailed test, and alternative hypothesis is mu not equal to 64. The test statistic, we must remember the formula: x bar minus mu by standard error, that is sigma by root n. And we know Z is a standard normal variable. Z follows N01. Z is a standard normal variable. Normal distribution with mean 0 and variance 1. What is the test criterion? If Z value, what I calculate, below 1.96, accept H0. Above 1.96, reject H0. So let us calculate what is Z value. Z is equal to the formula x bar minus mu by sigma by root n. X bar 63.5 minus mu 64 by sigma value 3 by root of n value 100. Find out the modulus of it. When I am in two-tailed test, we calculate the modulus. If I am in right-tailed, I see plus number. Left-tailed, I take it as minus number. But in two-tailed test, find out the modulus. Modulus. 63.5 minus 4. Find out and simplify the answer. We get mod Z 1.67, which is less than the level of significance value, critical value 1.96. Therefore, accept H naught. What is H naught actually? Mu equal to 64. What is the question actually? Is the difference in the mean significant? Whenever we accept H naught, we will say no significant difference in the mean. That is, we want to say this sample is from this population only. From sample mean to population mean, there is no difference. The sample is definitely from the population. Question number 15. A sample of 400 individuals has mean height 67.47 inches. Is it a sample from the population with mean height 67.39 inches and standard deviation 1.30 inches at 0.05 level of significance? It is the same as the previous problem, only the numbers are different. Here the sample of 400 individuals tells me sample size n is 400. The sample has mean height 67.47 inches. That is X bar. It is a sample from the population with mean. So population with mean height. So population mean, I take mu 67.39 inches. The standard deviation of the population sigma, that is 1.30 inches. Null hypothesis, as before, we will write mu equals 67.39. Alternative hypothesis, not equal. Mu not equal to 67.39. At 0.05 level of significance as mentioned in the question. Z alpha under two-tailed test, the value is 1.96. The test statistic, we know the formula. Mod Z is mod X bar minus mu by sigma by root n. Z value is a normal variate. Z follows N01. If Z value is below Z alpha, accept H naught, and if it is greater than or equal to Z alpha, reject H naught. It is a two-tailed test, so remember to put the modulus. Find out mod Z. What is mod Z? Modulus of X bar value 67.47 minus 67.39 by sigma value 1.30 by root of n, that is 400. Calculate. The value is 1.23, which is below 1.96. Therefore, accept H naught. What do you mean by accept H naught? This sample is from the population. The question is it a sample from this population? So we have decided. When we accept H naught, we say there is no difference between sample mean and population mean, and so the sample given is from the given population, and that is the answer. Question number 16. Average score of an aptitude test conducted at national level was 76 and standard deviation was 8. Average score tells me mean, standard deviation tells me 8, and it is kept at national level tells me this is mu and this is sigma. So mu value 76, standard deviation value 8. The state level 100 students are selected and their scores had an average of 72. So, students from the state 100. So, sample size n is 100 and their average tells me mean. So, x bar is 72 at 0.05 level. So, at 0.05 level, when it is a two-tailed test, the value is 1.96. If there is a significant difference, we have to check. So, same as the previous pattern, check whether mod z is below 1.96 or above 1.96. If it is below, the mean of sample and population are insignificant. The difference between the sample mean and population mean is insignificant, or I can say this sample is from the given population. If z value is more than 1.96, then reject H0. What is H0? Mu equals 76. And what is H1? Mu not equal to 76. The test statistic mod z value mod x bar minus mu by sigma by root n. And in all the problems, we remember to write z follows n01. Z is a normal variate, standard normal variate with mean 0 and variance 1. If z is below 1.96, accept H0, above or equal to 1.96, reject H0. Let us calculate z value. Mod z equals modulus of x bar 72 minus 76 by sigma value 8 by root of 100, that is minus 4 by 8 by 10, which is nothing but 5. So we get the value is definitely more than 1.96 and therefore reject H0. When you reject H0, we will say there is definitely difference between state scores and national scores. So we just conclude there is significant difference between state and national scores. Question number 17. The mean breaking strength of cables is 1800 and standard deviation 100. The mean breaking strength of cables, mean I call mu, standard deviation we call 100. So sigma is 100 and mu is 1800. By a new technique in the manufacturing process, it is claimed that the breaking strength of the cables has increased. Look at the word increased. That tells me mu greater than 1800. Unlike the other problems, it is one-tailed test. So these words give us the clue what test it is. Usually we say, is there a difference? Is there a significant difference? So those things are mu not equal to. When they give you the word increased or decreased, we use this. So H0, as usual, the null hypothesis mu equals 1800, whereas the alternative hypothesis in this problem, because of the word increased, by a technique they have improved. That is their claim. So mu greater than 1800. A sample of 50 tested. So sample of 50 tells me n value. The sample size is 50. The sample tested has the mean 1850. Sample mean is 1850. Now the question is, claim at 0.01 level of significance. At 0.01 level, if it is two-tailed test, the value is 2.58. But it is a single-tailed test, the value is 2.33. Because it is right-tailed test, we do not put modulus, only z we need to calculate. So what is z value? Z value is x bar minus mu by sigma by root n. Remember, two-tailed test we calculate modulus. In right-tailed or left-tailed you only find out z. And as usual, z follows standard normal distribution with mean 0 and variance 1. If z value is below z alpha, accept h0, above or equal, reject h0. It is one-tailed test, so don't put by 2. Remember. Let us calculate z value. Z equals x bar 1850 minus mu 1800 divided by sigma 100 by root n, root of 15. Find out the answer. We get z value is 3.53, which is greater than the scheduled value 2.33. Therefore, reject h0. What do you mean by this word reject h0? What is h0 actually? The population mean 1800, no change. If I reject h0, I will say the mean value has definitely increased. The question is, can you support the claim? So if I accept h0, I will say there is no change in the mean. If I reject h0, I will say definitely there is a change in the mean, and I will say we support the claim. As we read the problem, by a new technique, they claim the mean has increased. So h0 rejected tells me there is significant difference between sample mean and population mean. So we support the claim, and that is the answer. Example 8.12, we are discussing about confidence interval. Almost all the examples are of same pattern under this section. So let us see one such example. A sample of 100 measurements at breaking strength of cotton thread gave a mean of 7.4 and a standard deviation of 1.2 grams. Find 95% confidence limits for the mean breaking strength of cotton thread. Sample of 100 tells me sample size small n equals 100. Gave a mean of 7.4 tells me sample mean is 7.4 and standard deviation 1.2 grams. Usually, population standard deviation is that we need to do in the problem. But if it is not at all given, you can use the sample standard deviation as an approximation. So, sample standard deviation we denote yes, but I am taking it because sigma is unknown. Take it as an approximation for sigma, which is 1.2. The question is 95% confidence limits. At 95%, the value of Z alpha, we take 1.96. Standard error, we need to calculate. What is standard error? Sigma by root n. Here instead of sigma, we use S. 1.2 divided by root of n value 100. Root 100 is 10. 1.2 by 10 is 0.12. The formula for 95% confidence limits. How do we write it? X bar minus Z value into sigma by root n. This side X bar plus Z alpha sigma by root n. The question is confidence limits for the mean of the population. Mean of the population we call mu. So mu is between these two values. So this is an interval estimate. We are giving what may be the values for mu. From what to what? This is from lower limit. This is upper limit. Substitute and simplify. What is X bar value? 7.4 minus Z alpha The value is 1.96. Sigma by root n we have calculated 0.12. Less than mu less than. Again 7.4 plus 1.96 into 0.12. Multiply these two, subtract from 7.4, add with 7.4 and write the interval. 1.96 into 0.12 gives us 0.2352. Subtract, we get this answer. Add, we get this answer. Now, take and write the answer from the last line of the question. Mean breaking strength of cotton thread. The limits for the mean breaking strength of cotton thread is these two. 7.1648 starting number, ending number 7.6352. It is an open interval. This number first, this number second. So what we say, the limits, the population mean for breaking strength of cotton thread will be between 7.1648 to 7.635.